You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
I'm Frédéric Ladinois with The New Stack, and we're here with Chelsie Czop from Google, and you can give us your title because I always forget it.
Sounds good. I am a senior product manager for AI infrastructure on Google Cloud. A little bit of a mouthful.
Yeah, indeed. And AI infrastructure is a mouthful too. What is it that you do actually?
What is it that I do? That's a great question. It varies day to day. I sit across our entire AI infrastructure platform, so our GPUs, TPUs, and I help kind of bring that feedback loop from customers in and make sure that we're designing the right product and taking the right things into market and making sure that people are able to use them and get efficiency out of them. So that changes a lot every single day.
For sure. Well, you had the announcement here at Google Next about the new generation of TPUs, Ironwood.
Yes, I'm very excited about that one.
One thing that stood out for me was just how much more power there is now. Mm-hmm. How do you get to that point? What do you have to do to actually, because it's not a 1x improvement, right? It's quite a bit more than that.
Oh, that's a good question. We, to be able to design these systems too, it's interesting because you go back to the constraints that you have. It's power, it's thermal, being able to cool it. The more power you bring in, the hotter it gets, and then being able to interconnect all these chips together. So it comes incrementally, and then you look at it and you look back through the generations and you realize how far you've been able to come and how much that leap has been from the beginning.
Yeah, but were there major design changes you made with this generation compared to the last one? What does that look like? As far as you can talk about it.
The ones that I can talk about, well, we did get a 2x increase on performance per watt, too. So we were able to really balance the amount of performance you're able to get out of the watts. But as for the design changes, can't really talk about that.
Fair enough. I know you're excited about the liquid cooling, though. I'm sure that plays a part in this as well.
It is, yes. So we started doing liquid cooling. We're on our 4th generation now with Ironwood. And we started back in 2017 to be able to deploy it. And it is incredible what we're able to do at scale and how we're able to cool these chips. I mean, I remember being back when I was a hardware engineer, being in the lab trying to make sure we keep the chips cool and we have it all thermal coupled up. And the amount of efficiency that you're able to get out when you're liquid cooling is absolutely incredible. Mm-hmm. But obviously it comes with its own challenges. And just watching the evolution as to how Google's been able to evolve the liquid cooling every single generation, it's different when you and I talk about it, but then when you go into the data center and you see the little changes, like we run the liquid cooling pipes on the outside and the front of the systems when you're walking down the row. And one of the reasons we do that is so that you can visibly see if there's a leak. And from one generation to another, there's a spigot that's pointed up and one that's pointed down. I'm sure there were some lessons learned with that.
Yeah.
Yes. So the fact that we're able to do it at scale, to be able to keep all our chips cool and operating efficiently is incredibly impressive because I started working on a liquid cool system over 10 years ago, a long time ago, and it's incredible how much the technology has changed since then.
For sure, and you mentioned that we're not just talking about one chip, obviously. I think the largest one of these machines is 9,300 something.
Correct, 9,260.
All right.
Think I should probably double check that.
But you kind of mentioned the networking that has to go into that, right? And NVIDIA showed some of the photonics work they're doing at GTC a few weeks ago. How are you thinking about that aspect of just connecting all of these chips?
Yeah, so we connect all the machines through interchip interconnect, and so that relies on the ability for a light to be able to reflect between. So that's how we're able to scale up between pods and have such good connectivity in connecting over 9,000 chips in a single pod for TPUs. So That's our approach on the TPU
Got
side
it,
for
got it.
networking.
You're probably not telling us how far you're looking ahead, but are you looking at some of these other technologies as well too?
Oh, we're always looking at a lot of things.
I should have known you were going to say that. If you're thinking about the TPUs right now compared to a few generations ago, the workloads on them have changed as well, right? And some generations were more optimized maybe for training. This new generation, you're really thinking about inferencing. What's that relationship like between the software teams that are using these chips and the hardware teams that are building these chips?
That's a really important question to me because I love the hardware. My background's in hardware design, and I absolutely love to talk about it, but the hardware means nothing if you can't efficiently use it, if you can't keep the resources utilized, and if you can't easily deploy the applications you're working on. So that needs to be a tight relationship between the hardware and the software team. And the software team is what unlocks your capabilities to be able to do it, to port your inference over. So Google Cloud has always brought the AI research and innovation that we have in DeepMind and core Google into the cloud for everybody to be able to use. And we do the same with our software. And we're finally doing that with Pathways. We introduced Pathways for training and inference. And this is how we've trained Gemini, for example.
Explain Pathways for those who may not be familiar with that in the Google ecosystem.
The paper that we came up with in Pathways, we published in 2017, it helps us to be able to do distributed computing at scale for training and inference. So Pathways now, we're making it available for you to be able to use with TPUs and JAX on Google Cloud. So if you think about it, when you use TPUs, you're able to essentially harness everything in the research that Google's been able to do to train our foundational models like Gemini.
One thing I was thinking too is the software side and the models are developing so quickly. TPUs, they're basically on a 1-year cadence right now, I think it's fair to say, right? How are you keeping up with that?
That is a challenge. And honestly, with all the launches we've had on the GPU side and all the model architecture changes, it feels like there's something new coming out every single week. And then I saw a graph on just how much the model architectures have exponentially grown this year alone. Yeah. And we just wrapped Q1. It's crazy to me when you think about it, just that dichotomy that's so different from how much model architecture is changing, and then we're still on the steady cadence bringing the hardware to market. And that's where software really helps too, to be able to help you optimize and make the best use of the hardware that we have.
Sure. But the hardware cadence, it's going to be hard to speed that up necessarily, I would think. Are you thinking about that? Because that's rough.
It is rough. My background is hardware engineering. I came from IBM, so I got to do all sorts of different things there, mechanical, thermal, manufacturing, design of systems, and it was interesting because it, at the time, felt like a 3-year cadence we were on to be able to bring a system from inception through market. Yeah. And the first TGIF, our internal company meeting at Google, when I moved over to Google, completely blew my mind. It was the principal engineer of TPUs walking through how they brought the TPUs into the data center and how fast they were able to move. And it really confirmed I was in the right place. And it really was such a stark difference coming from IBM's design philosophies of everything is triple redundant in the machine to hardware is designed to fail. And how do you design software to be able to help and smooth that over that your applications don't run into that or face that?
Right.
So
does that mean you're also willing to take more risks with every new generation of TPU now?
Hopefully.
When you're thinking about, when the teams think about designing these chips right now, they have to think, I think what I'm getting at is they have to think about the next generation of models already. And we don't really know what that next generation of model is going to look like.
Exactly.
Are there what principle guides that? Like, what are the primitives there you're working from?
Yeah, we work very closely with DeepMind to be able to look at what's coming in the future. And it's kind of funny to me when we're writing our announcement blogs because we're like, we're designing this hardware for the next generation. And we're not even necessarily sure what those new model architectures are going to be. And so especially now we're focused on think time compute, bringing inference or training into the inference and thinking as you're doing the inferencing. And that is right now on the bleeding edge, but that could change next week.
Right, it seems to change every 6 months.
Exactly.
What's interesting to me is you also dealing with GPUs still.
Yes.
And how do you think about those two sides of, because you're building your own TPUs, you're buying GPUs, like what are you telling customers there, what they should use and how make the trade-offs that are made necessary there?
Oh, that's the question I always ask my customers when they, how they make those decisions. But it really depends on the use case. NVIDIA is such an incredible partner of ours, and they have such an incredible ecosystem, and they've really evolved from a hardware company into a software company to be able to unlock that value of it. And there's so much value in their entire ecosystem. So we will always be working with NVIDIA from that standpoint, and we're always wanting to bring their new hardware to the market first and work really closely with them. So we were actually the first cloud to bring a VM for B200 as well as GB200, so A4 and A4X are our VM names for it, to market with our customers, which was really exciting this year. So when you're looking at when customers would want to use one or the other, it depends on their workload, their use case, what their teams are already using. We want to meet customers where they are to be able to enable them. We've had customers that go from CPUs directly to TPUs. I was speaking with Moloco in a session earlier, and they had a 10x improvement just porting their training applications from CPUs over to TPUs. And they didn't even optimize they have very embedding heavy models, so they didn't even optimize for how they could use the sparse cores that are in TPUs to be able to do that. But at the same time, they still use GPUs as well. They use a lot of our products since we have a lot of global locations for them as well. So I think it's really a better together story. And what the use case is, maybe there's a framework that NVIDIA has that helps them to be able to do, or it's like a highly specialized industry use case to be able to do. But I think there's a lot of, it's not a one or the other. I think they're truly, you can use both.
Do your customers understand? Like, how much education do you need to give your customers on that?
Yes, that's something we're always working with our customers to be able to educate them and sometimes guide them based on the application or their use case that they're working on. For that, I mean, NVIDIA has an incredible education system too, and we've been building out how to make TPUs super simple to be able to adapt, and that's why we've been focusing on VLLM and making pathways available, because it's those software innovations that are going to make it so much easier for developers to be able to bring their applications over.
Sure. For developers too, it's a question, right? Which do I want to use? What works best for me? And can I take my workload from one to the other easily as well, right?
That's where VLLM is really useful for being able to easily port and test it out. Previously, I was a customer engineer, so I worked really closely with customers, and sometimes it's just best to test your workload out and see what works the best for you as well.
When you're thinking ahead right now, we can't give, obviously, we're going to see the next generation of TPUs next year, I'm sure, but kind of what are you excited about right now? What is it that you're thinking about?
I'm just excited that everybody else is excited about hardware, to be honest. I've spent my entire career focusing on compute and hardware, and finally my friends and neighbors actually know what I'm working on. So I think it's such an incredible, exciting time to be in this space.
Are you saying people weren't excited about the next CPU generation every year?
No, I think their eyes glazed over before when I'm working cloud computing, and now they're like, oh, NVIDIA, I've heard of NVIDIA.
Right,
or
right.
TPUs.
They haven't heard of TPUs yet, maybe. But
yeah, we're working on. As soon as my neighbors know what TPUs are, then I'll know.
you'll know. On the TPU front, though, I mean, actually, let's talk about the data centers in general.
Okay.
Because the one thing that I think, we talk power consumption and all of those issues, where are you building them, starting up nuclear reactors just to power these things, right? Like, what's the state of the art there, and where are we going with that, you think?
That is a great question. So I remember when I was that first company meeting on TPUs that I was at, where the principal engineer was speaking, I knew I wanted to go into a data center, especially coming from my background in hardware engineering. I lived in the lab, I just wanted to touch the hardware, and it is absolutely incredible to be able to go into a Google data center. Especially, I've been in smaller data centers,
sure,
but nothing at this scale. And I remember when open compute projects started, and I didn't fully understand the impacts of it until I saw the innovations that Google and other industries are bringing in and how it plays out at our data centers.
Sure.
So a few years ago, we introduced green concrete at open compute, but we're really thinking of everything from the ground up, literally the concrete that we build with, all the way to how do we do cooling, how do we bring and build AI into robotics on the machine floor or on the data center floor, and how can we make things more sustainable? Because at some point, it's fine when you have a small data center, but when you get into the Google scale, that really multiplies and just grows. So everything that we look at comes back to that. And I think you see a lot of our innovations at the data center level that we bring and donate to open compute so that others can be able to adopt these industry standards.
Yeah, but with the needs of AI right now outstripping almost the needs of everything else, is that are you reaching a point where you're constrained just by energy consumption and availability?
So I think back to when I wasn't around at Google then.
For sure.
When the greater team came up with TPUs, we looked at if every single user did a voice search on Google search, did we have enough compute? And turns out we didn't. We needed multiples of all the compute that we had deployed. So that's why we created TPUs, something that is specifically designed for AI to be able to do that processing. So with that, we did get some more energy efficiencies, and now we've been publishing those numbers and how we're able to improve the performance per watt that you get out of every single generation. So that is a big reason that we did look into creating our own silicon when we do that, so that we can make it as efficient as possible.
Sure.
So. Fair
enough. Is everything liquid cooled now in your data centers?
Not everything's liquid cooled. Ironwood will be liquid cooled, which is really exciting.
Previous TPU generations were too, you said?
It depends on the generation. So Trillium actually wasn't liquid cooled, but TPU V5P is liquid cooled. TPU V5E was not liquid cooled. I can't say they were all every other, but those are some of the latest ones that we did. It really depends on the trade-offs and the design that we have for the pod. Each cooling unit is able to go through an entire pod, which is incredible when you think of the scale that Ironwood's at, or even TPU V5P, the scale that pod was at. So it's really neat to be able to see and how it works and pumps the water through. And it's not even necessarily like cold water that you'd feel. It's the ambient temperature, room temperature water that's going through that's cooling these.
Yeah, I saw some of those racks that NVIDIA had out at GTC a few weeks ago, and they were liquid cooled, and it looks so different from the ones that were air cooled before, right? It's like quite the design challenge, I think, to make all of that work in these small packages now.
Yes. Here at Next, we do have a GB200 compute tray on the floor. So the really cool thing about, cool, pun intended, I guess, thing about that is it's NVIDIA's design of the compute, and then we have our custom liquid cooling that we brought on. And that's really our differentiator for our offering A4X of GB200, is that it's our liquid cooling that we've known and tested and deployed globally with the best of NVIDIA's GB200. And with the liquid cooling, the difference between the B200 and GB200, you get more flops out of it and more performance because you're able to keep these systems running at their optimal temperature.
Got it. Thank you, Chelsie.
Yeah, of course.
Appreciate it.
Yeah.
We'll do it again soon.
Yeah, that would be great. This was fun.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.